Hello everyone. So today we will be discussing about the second topic in equilibrium chapter. So in the first video we have seen what is equilibrium constant. Now we will see the properties of equilibrium constant. In Kc. Okay. So the first property is if there is a reaction, let's call it like the formation of ammonia. So if there is a reaction like this for the formation of an ammonia, then I have discussed in the previous video that we can write its Kc like this: product concentration, which is ammonia in this case, to the power coefficient, and then in the denominator, the numerator, in the denominator, the reaction will come like N2 to the power 1 and H2 to the power 3. Okay. So this is the Kc for this reaction. So if we divide this whole reaction by a fraction of 2, so it will become like this. Okay, so this is for the 2 mole of formation of any ammonia, and this is for the 1 mole of formation of ammonia. So the Kc value for this, let's say its Kc dash will be this: NH3 to the power 1, N2 to the power 1 by 2, because their coefficient is 1 by 2, and H2 to the power 3 by 2. Okay, so these are the equilibrium constant for the corresponding reaction. So if you look closely, then you can find out that the Kc is equals to Kc dash is equals to under root of Kc, which means if we take the under root of this Kc, then we will get the Kc dash. Okay, so it means if we divide the whole reaction by a factor of 2, then its equilibrium constant will become the square root of the original equilibrium constant. Okay, like this. And the second one is same as this. So for this I am taking the example of formation of Hi. H2 plus I2 is giving 2Hi. Okay. So for this the Kc will be Hi to the power 2 and then H to the power 1 and I to the power 1. So if we multiply this reaction by a factor of 2, then it will become 2H2 plus 2I2 giving 4Hi. Okay. So if we write the Kc for this, it will be Hi to the power 4 and then H to the power 2 and I to the power 2. Okay. So now if we see closely, then we find out that Kc dash is the square of Kc. So if we multiply a given reaction by a factor of 2, then its equilibrium constant will become the square of the original one. Okay. So these are the two properties. Then the third property is dependence on temperature. Okay, so if we have two equilibrium constant at two different temperatures, then the relation is log K2 by K1 is equals to delta H 2.303 R T2 minus T1 T2. So this equation is called Bond-Hoff equation. And this equation summarizes the dependence of equilibrium constant on the temperature. So if we have the equilibrium constant at one temperature, then we can find out the equilibrium constant at another temperature, where this delta F is enthalpy of reaction. Okay, so these are the three properties of equilibrium constant. So this is all about this video.